there, folks. Elvis PEMDAS here, back talking to you about simplifying and estimating square roots. Now here's a question. What do the Smurfs celebrate on December 25th? That's going to be a blue Christmas.
First thing we're going to talk about is a numerator. That is the number or expression above the line in a common fraction. So here you see 9/16. Our numerator is going to be in the top, whereas the denominator is the number or expression below the line in a common fraction. So in this 9/16, this 16 would be our denominator. The next vocabulary term is a perfect square. That is the square of an integer. Here, all of the green numbers represent perfect squares. You can tell they're perfect squares because they're equal to an integer squared. Here you only see the natural numbers, but we could have -1 squared, -2 squared, -3 squared. They would still equal these numbers in green. So you will be responsible for memorizing the perfect squares from 1 to 225. You need to memorize each of these perfect squares. We will use those when we talk about simplifying radicals later on. Next vocabulary term is a square root of a number. That's a value that when multiplied by itself gives the original number, also called the opposite of squaring a number. So if you know how to square a number, this goes the opposite way. If I take rad 3 and multiply it by itself, I should end up with the original number, the number that's inside 3. Now how does this work? Well, rad 3 times rad 3, you multiply the numbers inside, you get rad 9. Now 9 we can rewrite as 3 squared. Now notice that the radical and the square are inverse operations, so they cancel each other out. That's why we're left with 3. Now this is called the radical sign, whereas the number inside is called the radicand, what you're taking the radical of, the square root of.
What do you call the king of the sea? That would be Elfish Presley. Example time.
Now, example 1 says simplify each expression. So we're going to simplify it like we did in the previous vocabulary term. We're going to take 25 and ask ourselves what squared equals 25. That answer is 5. So we're going to rewrite 25 as 5 squared. Now we do that because we can see now that the radical and the square right here, this 2, cancel each other out and we're left with 5. And that's your answer. Let's go over to the square root of 121. Again, we asked ourselves if we were to multiply some number by itself, what equals 121? That answer is 11. So we change this to 11 squared. And the square root of 11 squared, again, the radical and the square cancel each other out. You get 11. 0.36, this one's a little tougher. Think about just 36. What number multiplied by itself equals 36? That would be 6. Well, since we have 0.36, it stands to reason that 0.6 squared would equal 0.36. So we're going to change that 0.36 to 0.6 squared. Now what we can do is cancel the radical and the square out, and we just are left with 0.6. Lastly, we have 0.16, so just like over here, think about just 16. What number multiplied by itself would equal 16? That's 4. So we're going to change 0.16 to 0.4 squared. Now the radical and the square cancel each other out. You're left with 0.4.
What did Elvis say to the bully? Don't be cruel. Do heartless true. You try.
Okay, the square root of 49. So 49 is equal to 7 squared. We then can cancel out the radical and the square. We're just left with 7. Over here, 100 is equal to 10 squared. We can then cancel out the radical and the square. We're left with 10. Down here, 0.64. Just like last time, let's just look at 64. What number squared equals 64? That's actually 8. So if we're looking for what number squared equals 0.64, then that would be 0.8. We can then cancel out the square root and the square. We're left with 0.8. Lastly, we have 1.44. Even more tricky. Let's just think about 144. What number squared would equal 144? That's 12. But since it's 1.44, then we're going to change this to 1.2 squared instead of 12. So then the square root and the square now cancel each other out and we're left with 1.2. Later on, you're going to get better at this and you're not going to need this middle step. And you can just jump from here to your answer. Let's talk about simplifying fractions under a square root. So to simplify a fraction under the square root, just take the square root of the numerator and denominator. Everybody freaks out when they see the square root of a big fraction like this. All you have to do is just rewrite it so that it's not a big square root and a fraction. It's just the square root of the numerator and the square root of the denominator. Here, square root of 4 we know is 2. Square root of 9 is 3. That's all you had to do here. That's your answer. Okay, example 2 says simplify each expression where we have the square root of a fraction. And we just said when we have the square root of a fraction, you rewrite it so that's the square root of the numerator over the square root of the denominator. Now we can figure out what number squared is equal to 16. That's 4, so we rewrite that as 4 squared. What number squared is equal to 81? That's 9, so we rewrite that as 9 squared. Now the radical and the squares cancel each other out in the numerator and denominator. We're left with 4 over 9. Now again, when you get this, make sure you check that it can't be simplified any further. Is there any number that divides in the numerator and denominator? No, that's why we're done. Part B, square root of 25 over 196. Again, we rewrite it so it's the square root of the numerator over the square root of the denominator. Now, what number squared is equal to 25? That's 5. What number squared is equal to 196? That's 14. So we rewrite those. And now the radical and the squares cancel each other out in the numerator and denominator. We're left with 5 over 14. Again, always check, is there any number that divides into both the numerator and denominator? No. Square root of 36 over 225. We rewrite it so it's the square root of the numerator over the square root of the denominator. What number squared is equal to 36? 6. What number squared is equal to 225? 15. So we have 6 squared and 15 squared. We substitute those in. Now the square root and the squares will cancel each other out here. And again, we're going to get 6 over 15. And we ask ourselves, is there a number that divides into both of these? Yes, actually this time. We can divide 3 into our numerator and get 2, and divide 3 into our denominator and get 5. That's why you need to check. Lastly, we have the square root of 144 over 64. We rewrite it so it's the square root of the numerator over the square root of the denominator. What number squared is equal to 144? That's 12, so we rewrite that as 12 squared. And then 64, that's going to be 8, so 8 squared we plug in for 64. The square root and the squares cancel each other out, and we are left with 12 over 8. But again, can we simplify this? Yes, we can actually divide 4 into each of these. So I get 3 over 2 as my final answer.
Here we go, Elvis, here we go. You try.
Okay, so again, we rewrite it with the square root of our numerator and denominator. We are going to ask ourselves what number squared is equal to 49? That's going to be 7, so we rewrite 49 as 7 squared. What number squared is equal to 4? That's 2, so we rewrite that as 2 squared. Now we can cancel out the radical and the square in the numerator and denominator. We're left with 7 over 2 as our final answer. Again, nothing can divide into each of these, so we're done. So again, we rewrite it with the square root of our numerator and denominator. We then figure out what number squared is equal to 9? 3. So we rewrite that as 3 squared. What number squared is equal to 100? That's 10. So we rewrite that as 10 squared. Now the square root and the squares cancel each other out. We're left with 3 over 10. Nothing divides into each of those. We're done. Same thing for part C. We break it up so that it's the square root of the numerator over the square root of the denominator. What number squared is equal to 196? That's 14. What number squared is equal to 169? That's 13. So we have the square root of 14 squared over the square root of 13 squared. The radical and the square cancel each other out in the numerator and denominator. We're left with 14 over 3. Here, we again take the square root of the numerator over the square root of the denominator. 36 we turn into 6 squared, and then 144 we turn into 12 squared. Now, the radical and the square cancel each other out in the numerator and denominator. We are left with 6 over 12. Now, this can be simplified. Is there a number that divides into the numerator and denominator? Yes, divide 6 into the numerator and denominator, and you're left with 1/2. Example 3 says estimate the square root by explaining which integer it is greater than or less than. So we have the square root of 8. That is not a perfect square. 8 is not a perfect square. However, 9 we know is a perfect square, and that is very close to 8. So we're going to say the square root of 8 must be a little less than the square root of 9. Now, the square root of 9, we just learned, we can rewrite as 3 squared. Now notice that the radical and the square are inverse operations, so they cancel each other out. That's why we're left with 3. So we know that the square root of 8 must be a little bit less than 3. That's how we work on estimating square roots. Let's try that again. So we have the square root of 17. 17, not a perfect square. But what perfect square is it close to? It's close to 16. So we can say that the square root of 17 must be a little bit greater than the square root of 16. And now what is the square root of 16? Well, 16 is the same as 4 squared, and this radical and the square can cancel each other out. That's 4. So the square root of 17 must be a little bit greater than 4.
Why did Elvis's soda can explode on him? 'Cause it was all shook up. Oh, you try.
Okay, here we have the square root of 223. That is not a perfect square, but what is 223 close to? That is a perfect square. That would be 225. So we know the square root of 223 must be a little bit less than the square root of 225. So what is the square root of 225? Well, 225 is the same as 15 squared, and this radical and square cancel each other out. So we're left with the square root of 223 being a little bit less than 15. Over here, we have the square root of 50. Again, 50 not a perfect square, but it's close to 49, which is a perfect square. And we say that the square root of 50 is a little bit greater than the square root of 49. Now, what is the square root of 49? Well, 49 is 7 squared, and the radical and the square cancel each other out. We're left with 7. So the square root of 50 must be a little bit greater than 7. Example 4 says, without using a calculator, order the numbers in each exercise from least to greatest. So let's go ahead and do that. First, we start with our negatives, right? Because those are going to be our least values. So how do I figure out what this is approximately? Well, let's change it to a mixed number. How many times is 11 going to 60? That would be 5 times with a remainder of 5. So this is the same as negative 5 and 5 11ths. Now we see that that is clearly our least value. So we're going to start our list with negative 60 over 11. Other negative number is that negative 3, so we put that here. We then have to decide between these 3 positive values. So let's figure out what these radicals are. First, rad 32. 32 is not a perfect square, but it is close to 36, which is a perfect square. So rad 32 must be a little bit less than rad 36. We pick rad 36 because we know what the square root of 36 is. 36 is the same as 6 squared, and these cancel out, so we just get 6. So that means that rad 32 must be a little bit less than 6. Next, we figure out what rad 11 is. Rad 11 is a little bit more than rad 9. Why did we pick 9? Because 9 is a perfect square. We can take the square root of 9. Square root of 9, remember 9 is 3 squared. The square root and the square cancel each other out, and we get rad 11 is a little bit more than 3. So now that we know that, we can then put these 3 numbers in order. The number that is a little bit greater than 3, that would be rad 11. Then it's going to be this 5.5 right here. And lastly, rad 32, which is a little bit less than 6, we put here. And we're done.
Look at me, I'm dancing 'cause I'm Elvis and I'm a good dancer. You try.
Okay, so we're doing the same thing here. We first rewrite this guy as negative 3 and 1/3. Now we know between our negatives which is less. Negative 3 and 1/3 is the same as negative 3.333333. So that is actually less than negative 3.1. So this is going to go first, then this number right here, negative 3.1. Now we decide between our positive numbers. So we need to figure out what these radicals are. Let's start with rad 15. Rad 15 is very close to rad 16. We picked 16 because we know what the square root of 16 is. 16 is a perfect square. 16 is the same as 4 squared, and the radical and the square cancel each other out. We're left with 4. That means rad 15 is a little bit less than 4. Now let's look at rad 8. We can't take the square root of 8, just like we couldn't take the square root of 15. That's why we had to estimate what it was. So rad 8, we can't take the square root of it. What perfect square is it close to? What perfect square is 8 close to? That would be 9. So we can say that rad 8 must be a little bit less than rad 9. Now, we do this because we know what the square root of 9 is. 9 is the same as 3 squared. The square root and the square cancel each other out. We're just left with 3. So rad 8 must be a little bit less than 3 because rad 8 is a little bit less than rad 9. Now that we know this, we can then reorder or order these 3 positive values. If rad 8 is a little bit less than 3, we can say that that would go before 3. So it's going to be rad 8, then 3, because rad 15 is a little bit less than 4, so that means it's greater than 3. And then we can say rad 15, and we're done.